Its 36-year mission to explore strange new worlds, to seek out anomalous cosmic rays and new plasmas, to boldly go where no probe has gone before. The Voyager 1 has been making its way through outer space for over 4 decades now, and in that time it's gone above and beyond its initial mission. The spacecraft was only expected to survive for 5 years, but it's proven all estimates wrong. But now it's gone a step further. Voyager 1 just detected unknown objects passing by in space, and well, it's changed everything. The plasma comes from the explosion, has from other giant stars millions of years ago, and that plasma carries with it the magnetic field of the galaxy. Thank you. Join us as we uncover what these unknown objects were and how it might change the way we've looked at data forever. While for the past few years we've mainly just looked at data from inside the solar system, thanks to the Voyager 1, we now have access to data from outside too. In August 2012, the Voyager officially reached the end of the solar system and crossed the heliopause. But this wasn't an easy task whatsoever. As Voyager 1 moved farther away from the Sun, the amount of sunlight available to power its instruments and systems diminished significantly. The spacecraft's power is primarily generated by 3 radioisotope thermoelectric generators, rugs that convert the heat produced by the natural decay of plutonium-238 into electricity. Over time, the decreasing heat output of the rugs has resulted in a decline in available power. This reduction in power affects the operation of various systems on board, including scientific instruments, data transmission, and communication capabilities. To conserve energy, certain non-essential systems and instruments have been deactivated or placed in a dormant state. As the power continues to decline, critical systems may need to be further optimized or shut down to extend Voyager 1's operational lifespan, because as is, it won't be able to operate for much longer, and even if it does, it might not end up being of much use to us. That's because the vast distance between Voyager 1 and Earth also presents a significant challenge in maintaining effective communication. As the spacecraft ventured into interstellar space, the signal strength from Voyager 1 weakened considerably. Right now, it takes over 21 hours for signals to travel from Voyager 1 to Earth. The weak signal, combined with the interference from background noise, poses a substantial obstacle to successful data transmission and reception. Add to that the temperature transitioning from the heliosphere to interstellar space exposes Voyager 1 to different temperature conditions within the heliosphere. The spacecraft was closer to the Sun and experienced higher temperatures. As it ventured into interstellar space, it encountered extremely low temperatures. These temperature extremes can impact the spacecraft's materials, electronic components, and systems. Thermal stress and thermal expansion and contraction cycles might affect the structural integrity of certain parts. Extreme cold can cause materials to become brittle, potentially leading to fractures or degradation of seals and connectors. The temperature variations also influence the performance of the rugs, which are designed to operate within specific thermal ranges. The cooling of the rugs reduces the power output, further exacerbating the power challenges we've gone over earlier. This problem gets even worse because, you see, interstellar space isn't entirely empty. It contains a sparse distribution of dust particles. While these particles are minuscule in size, they can pose a risk to the Voyager 1 spacecraft. When the spacecraft encounters interstellar dust, the particles can collide with its exterior surfaces. Over time, these impacts can cause wear and tear on the protective coatings, antenna surfaces, or other sensitive areas of the spacecraft. The accumulation of dust on the instrument's optics or sensors can interfere with their functionality, degrading data quality. Voyager 1 carries a dust detector instrument specifically designed to measure the density of interstellar dust. But it's not just that. The Deep Space Network, NASA's global system of antennas for communicating with deep space missions, has to allocate limited resources to receive Voyager 1 signals, making communication opportunities a lot more infrequent than they've ever been before. The continuous decrease in signal strength further complicates data retrieval and reliable command transmission. But even then, each piece of information has to be thoroughly analyzed, no matter how crazy it might sound. Recently, though, amidst the stream of data, a fascinating discovery emerged. Voyager 1 detected an intriguing anomaly. There were a bunch of signals, most of them hard to decipher, but one of them said that it detected the presence of 300 unknown objects passing by in the cosmic expanse. These mysterious entities Emerging from the depths of interstellar space had scientists all over the world. The recent discovery of 300 unidentified objects has challenged our understanding of the cosmos. Are they remnants of ancient celestial bodies or signs of unknown phenomena? The data transmitted by Voyager 1 was scrambled and raised many questions without providing answers. Despite this, Voyager 1 remained in remarkable condition and maintained communication with Earth. The spacecraft's fault protection systems were not triggered, indicating it was not under attack. But the scrambled data remains unknown. Researchers at NASA are working to understand the cause of the scrambled data transmitted by Voyager 1. They considered factors such as radiation, temperature fluctuations, cosmic noise interference, and trajectory shifts. The team analyzed the spacecraft systems using advanced data processing techniques, innovative algorithms, and simulations. After weeks of research, the clarity and reliability of the spacecraft's transmission have been restored. The problem with Voyager 1's data transmission was traced back to its Attitude Articulation and Control System, AACS, utilizing a dormant onboard computer. Despite the corruption of the transmitted data, the rest of the spacecraft remained operational. Engineers sent a command to switch the AACS system to the correct computer, fixing the issue. Troubleshooting required coordination and referencing manuals from the 70s. By resetting the data transmission system, the engineers successfully restored Voyager 1's communication. Their expertise and dedication highlight the importance of combining past knowledge with present technology in overcoming space exploration challenges. Engineers suspect that Voyager 1's deviation into utilizing a non-operational computer was triggered by a faulty command from another onboard system. Despite this concern, mission managers remain optimistic as the incident does not pose significant threat to Voyager 1's long-term well-being. Voyager 1 successfully reached the heliopause, the outer boundary of the solar system marked by the Sun's solar wind reaching the interstellar medium. The heliopause is subject to fluctuations and shaped by the Sun's motion through space. Crossing the heliopause led to a drop in temperature, a change in magnetic field direction, and an increase in galactic cosmic rays. Voyager 2 also crossed the heliopause, providing further insights into this celestial frontier. Voyager 2's encounters added to our understanding of the unexplored region, including a sharp decrease in low-energy ions beyond the Sun's influence. Voyager 2 detected an increase in the intensity of cosmic rays from distant sources. Unlike Voyager 1, which experienced precursor events before leaving the heliosphere, Voyager 2 encountered a distinct boundary layer just beyond the heliopause. In this boundary layer, low-energy particles streamed outward along the Milky Way, revealing the complex dynamics between our solar system and the interstellar medium. This finding highlighted the unpredictability of the interstellar boundary and the challenges faced by future spacecraft. NASA is planning to launch the Interstellar Probe between 2036 and 2041 to gather comprehensive measurements and insights into the heliosphere and heliosheath. The Interstellar Probe represents a significant leap forward in interstellar exploration and will pave the way for future missions